Hello everyone, welcome to the second part of the lesson on three-dimensional geometry. In this lesson, we shall solve question number 20, KCSE 2013, paper 2. Let's begin. The figure ABCDEF below represents a roof of a house. AB is equals to DC is equals to 12 meters. BC is equals to AD is equals to 6 meters. AE is equals to BF is equals to CF is equals to DE is equals to 5 meters. And EF is equals to 8 meters. So that is the figure. Let's go to the questions. Calculate, that is part A, correct two decimal places, the perpendicular distance of EF from the plane ABCD. Then we have the second part of the question. Calculate the angle between, part 1, the planes ADE and ABCD. 2, the line AE and the plane ABCD, correct to one decimal place. Then part 3, the planes ABFE and DCFE, correct to one decimal place. So those are the questions that we need to answer. So from the diagram, let us feed in the figures or the measurements as they are. So BCAD is 6, BCAD, so this is 6, so this one is 6. So we have another measurement AE, BF, CF, DE is equals to 5. So BF, so all these, this is 5, this is 5, this is 5, this is 5. Then EF is 8, EF is 8, and AB is 12. So this is 12 and this is 12. So those are the measurements. Now let's go to the first part of the question. Calculate, correct to two decimal places, the perpendicular distance of EF from the plane ABCD. The perpendicular distance of EF from the plane, from the base. So we need to get that perpendicular height. So this is how we can get this perpendicular height. It's something that we need to draw. So we can draw it like this. The perpendicular height. It may not look accurate since because of the diagram, but just going to try. So that is the perpendicular height, assuming that this is the base and then this is the from EF. So that is the perpendicular height. So in order to get that, we need to form a triangle, and this is a triangle that we shall form. So this one being 90 degrees, we need to draw the slant height of, let us have this slant height, which will be very crucial in helping us work out these. At the slant height here, we shall create a slant height. So that is a slant height. Sorry. So now having this a triangle, we can label this as O, the base is O, and we can label this as N. So we have now triangle ENO, and this will be very crucial in helping us get that perpendicular distance. Now let's get the slant height EN. So the slant height, EN, you can see it from the diagram there, slant height EN. So to get that slant height, we shall consider we use triangle AED. So use triangle AED. These will be very important. So when you look at that triangle, we can extract it. We can extract that triangle here. Just a sketch. We'll draw a better one. So that is triangle. This is AED. So AED. So the slant height that we have is this. This is the slant height. Sorry. Let me draw a better line here. So that is the slant height. The slant height EN. So this is EN. So to obtain that, since we have this is 5, this is 5, and of course this side will be, this will be 3, and then this will be 3. So we have this is 3, and this is 3. So the slant height EN is obtained by getting the square root of 5 squared minus 3 squared. This gives 25 minus 9, which is the root of 16, and this will be 4. So that is 4 meters. So this slant height will be 4. So having that is 4, in triangle ENO, we have the one side only. That is what you know. So we need to get NO. We need to get NO. And to get NO, there's something here that we need to get, which will help us. So we can draw a line. This is a line that we can draw here, which will be very helpful. Now having this line, you realize these will be from DC. DC is 12, which is AB. Then EF is 8. So in the middle here we have let's say up to that point, this is where we have E. This will be 8. So this side will be 2, and this will be 2. So also still we can use these. So this side, so this one will be 2. Since this one, let me draw a line from here. I think this will be better. If I draw another line here, I'm looking for a line that will help us. That is the line. Let me draw a better one. diagram is not drawn accurately. That is why it's giving us a bit of hard time. So from this point to where F is, that is 8. So we have this end which will be 2 and this end will be 2. That is what I mean. So therefore, looking at this side, NO will be 2. NO will drop, create more space here. So NO will be 2 meters. And we've obtained 2 meters by the fact that using EF, when you look at line EF is 8. So EF starts from here to this point. We have drawn that. That is EF. That is 8. So the remaining parts, both to the right and to the left, are equal. And you must get the whole of that distance. AB is 12. So the remaining 4 meters you divide it between the two ends. So you get from this end 2 and 2. And this is where we have these 2. So when you drop these perpendicular from E to this point, to that point E, that point O, you get this end NO being 2. Then if you drop another one, there's something I have to remove here. So if you drop another perpendicular, I think I can drop it. If we drop another perpendicular here, so FO again, we can call this point, you can just, so this is what you mean. You can see, or we can label this as K, label this one as K as well instead of O. So you can see point OK is 8, is the same with EF. Then the two ends NO and K, so these are M and KM, both of them will be 2, 2. So that the whole distance is 12. So that is how we come up with these 2. So we can use this end. The right hand side can also give us the perpendicular height, and also the other end, the left hand side. So we can obtain that perpendicular height using those 2 means. So let us now extract our triangle ENO using triangle ENO. You can see it from the diagram here, ENO. So this is how it looks like. So the perpendicular distance is EO. Use EO. And then this slant height is EN. So we've got the slant height to be 4. And then we have NO as 2. So now the perpendicular distance, is given by 4 squared minus 2 squared. You get the square root of this. So this will give 16 minus 4, which you can give as the root of 12, or you can get the root of 12 as 3.46 meters. So you can give the answer in root form, in surd form, or in decimal. So that is how you're supposed to get the perpendicular distance. So by simply drawing those important triangles, extracting them, and taking note of all the measurements. Let's go to part 2. Part 2 is now you're getting the angle between the planes ADE, and ABCD. ADE, you can see where ADE is, and planes ABCD. So that is the angle between the two planes. Now, from the first working, we've made everything to be easy, since that angle between planes ADE and ABCD will be given by this. This is the angle. So that is the required angle. So we shall just use, just looking at the extraction that we've done, the angle at N, this is the angle that we need to get. So we just need to take that triangle and calculate. That will be easy. It will be very easy. So we just need to copy this. This is EON. So this is the angle that we need to get. And since we have the height, we have EO. So the perpendicular height here was EO. So EO is equals to 3.46. Then this was 4, this is 2. So to get that angle, that would be now the angle. This angle represents the angle between the plane ADE and the base ABCD. So that is the angle. So to get that, we can use trigonometric ratios. In this case, we can use tangent or cosine or sine any. So let me choose to use tangent. So tangent of this angle is opposite of adjacent, or you can just give it in surd form, root of 12 over 2. So this gives 1.732. So theta will be given by tan inverse of 1.732, which gives 59.999 degrees. So this one, approximately to 4 significant figures, this will give 60 degrees. So that is the angle between the plane ADE and ABCD. Now let's go to the other part of the question. Which is the line AE and the plane ABCD. The angle between line AE and the plane ABCD. Let's go to line AE and the plane ABCD. So what we need to get is the projection of AE. Need to get the projection. Get the projection of AE on plane ABCD. So that is very important. So the projection of AE will be AO. So let me draw the projection. So the projection will be there. So that is the projection. The projection of AE on plane ABCD is AO. You can see AO. And since you want to get the angle will be given by, so this will be the angle. So this will be the angle. So let us extract that triangle. So we shall extract, we form triangle. So let's extract the triangle AEO. AEO. That is what you're going to use. Triangle AEO. So we want to extract that triangle AEO, as you can see. So AEO, the right angle, okay. So that is the triangle. So it is right angle at that point. So we have AO. So A is there, E is there, and O is there. So putting the measurements that we have, we have EO is the height, we got that, and AE is 5. AE is 5, EO, we got it. So AE is 5, and then this we got this one as root of 12, all 3.46. 3.46. Now having that, we can get this angle. This is now the angle between that line AE and the plane ABCD. So simply get the angle between that line and its projection, and that is the angle. So use trigonometric ratios. In this case, we're going to use sine. So sine of that angle will be given by opposite, which is root of 12, or you can write 3.46 divided by hypotenuse. And theta, therefore, that angle will be given by the sine inverse of root of 12 divided by 5. So this gives 43.9 degrees. That is correct one decimal place. That is how you get the angle between the line AE and the plane ABCD. Let's go to the last part of the question. The planes ABFE and DCFE. ABFE and DCFE. ABFE, let's see it from the diagram. ABFE and DCFE. You can see those two planes, ABFE and DCFE. So to get that angle, there's something we need to do, and we can draw something here. You can draw a line, and then you draw another one here. You have these, and since we have this perpendicular height, sorry for these. That is better now. So the angle that we need is this angle. This is the angle that we need. You can call that angle alpha. That is the angle that we need between those two planes. There are planes that are slanting. One is slanting this side, the other one is that. So we already have all these. Measurements, so we can just feed them. We can just feed them. This is 3. This is 3. We got this. The perpendicular height. We have it. We have the perpendicular height. We have the slanting height. So we only need to extract that triangle. We can extract. So we can call this point J. So and then this is don't need to even label it. We can extract this triangle that we have here. Let's extract it since you can see it. So what we have is this is the right angle. So we require the whole of this angle. That is what we require from the diagram, as you can see. So we have, this is 3, 3. So we have this is 3, this is 3. Perpendicular height is root of 12 or 3.46. So you can call this as theta and theta. So we need to get one angle and we multiply it by 2. So we can use we can use tangent to get this. Tangent of theta using one triangle given by opposite over adjacent. So since you can see there, we need to get one angle and then multiply it by 2. Therefore we can give this one as, so this alpha will be given by tan inverse of 3 divided by 12, and then we multiply this by 2 to get the entire of that angle. So when you do this working, this is what you get. You get tan, this will be tan inverse of 0.866, and this gives 40.91. We multiply it by 2. This will give, we're required to give the answer to one decimal place, so we get 81.8 degrees. So that is how we're supposed to work out that question.